Hey everyone, and welcome back to Hoffman Engineering. Recently I've been using the TiVo Tornado. This printer has a 12-inch by 12-inch by 16-inch build area, which is massive. However, it comes with your standard 0.4mm nozzle, so prints that fill up that entire volume take a long time. So I picked up this. This is a kit that comes with a bunch of different sized nozzles. Everything from 0.2mm all the way up to 1mm nozzles. So what I'm going to do today is I'm going to actually swap out the 0.4mm nozzle and I'm going to try a 0.8mm nozzle. So let's get this thing torn apart. Let's put on this new nozzle and let's talk about what nozzle size actually does for your prints. So let's get to it. So to swap out the nozzle, it actually doesn't take a whole lot. Obviously, you need the nozzle that you're going to be replacing. Now, luckily, a lot of 3D printers use a standard size thread for your nozzles. So just take a quick look on the internet to see if anyone has suggestions for your particular hot end. I'll have links to what I'm using down below. Besides that, you'll need tools to actually get to your hot end, some various size Allen wrenches. It all depends on what printer you actually have. Then it'll be helpful to have some Kapton tape to help seal everything. There's usually going to be some kind of covering over your heater block to help insulate it. So Kapton tape will help when we cut that open. We can wrap this back up and get it nice and secured. And then finally, you'll want a actual wrench for the size of the nozzle that you have. This will actually fit around the nozzle itself and allow you to tighten and loosen really securely without damaging the nozzle. For these nozzles, it looks like a 6mm wrench is what we're looking for, but this may change depending on the nozzle that you actually picked up. So just find the right one for your printer. So before we can change the nozzle, we actually have to get access to the hot end itself. So for me, for the TiVo, I need to remove this covering from the hot end. So I'm just going to grab an Allen wrench and undo these two screws, and that should allow me to remove the covering. And there we go. So with the cover out of the way, we now have access to the hot end itself. But in order to get even better access, I'm going to actually undo these screws, securing the hot end to that back plate. So now that I have access to the hot end, I'm going to take a pair of pliers and securely hold on to the heater block here. I'm actually going to try to do it without removing the insulation around the hot end. We'll see if that lets me get a good hold of the hot end, but without scratching that heater block. But if it becomes an issue, I can always just take an X-Acto knife and cut away this insulation, and then we can use that Kapton tape to secure it afterwards. In order to remove the old nozzle, I actually have the hot end temp set to 240 Celsius. You're going to want to heat up the hot end because that will let things expand and that'll actually loosen up the nozzle. If you try to do this at room temperature, that nozzle will actually be way too tight. So make sure to actually have that heater heated before removing the nozzle. So now we can take our wrench and I'm going to place that around the nozzle, and hopefully we can remove this. And there we go. That wasn't too difficult. We'll just remove the old nozzle. And to replace it, I'm going to grab one of the 0.8mm nozzles and we'll start threading it in by hand, making sure not to hit the hot heater block, so be careful. And once it's a little bit in there, take the same wrench and we will tighten that up. And we'll let that heat up for just a few more moments. Once everything's heated though, we can grab our wrench and we can make sure that everything is nice and snug. If you try to tighten this again while it's at room temperature, it just won't get tight. And when it heats up, you'll actually have filaments and plastic leak out from around the nozzle. But doing this at a temperature higher than you normally print with will make sure that everything is nice and tight. at your normal printer temperature. You may want to be careful. These wrenches will heat up because it's in contact with the metal nozzle. But once you are pretty well sure that everything is as tight as you can get it, we can tell it to start to cool down. And there we go. We have a replaced nozzle. Now let's go ahead and reassemble that hot end. And now that we've replaced the nozzle, let's put some filament into it and see if we have any leaks. If we didn't have the hot end heated up enough, or we didn't tighten down the new hot end enough, then that could be an issue. And we'll have leaking plastic from not just out of the nozzle, but around the nozzle or around the heater block. So I'm just going to feed some filament through it. We do see a nice thick strand of filaments coming out of the hot end. And now that I've fed a decent amount of filament through, I can take a look at underneath and see if there's any plastic coming out of anywhere else besides the nozzle. And I don't see anything yet, so I think that we might be good. We will keep an eye on this as we do our first prints, and if anything's loose, we'll come back in and tighten it up. And here we can see the difference that the nozzle diameter makes. You can see which one is done with the 0.4 millimeter and which one was done with the 0.8 millimeter. It is crazy. And because the new nozzle is a little bit taller than the old one, we will have to adjust the Z-axis home just to account for that difference in nozzle length. But adjusting the Z home is not that bad. So our first test print with the new 0.8 millimeter nozzle is done, and it looks great. I didn't have to change anything in Cura besides updating the nozzle diameter to 0.8 millimeters, and it looks like it printed pretty good. I may have to make a few tweaks, but otherwise I am impressed already. This was a 20 millimeter cube printed at 0.4 millimeter layer heights, and it took about 11 minutes to print. So let's pop this off the build plates. And so with the cube off the build plate, we can take a closer look at it. The top surface looks great. There's no noticeable gaps, so that is good. If you take a look at the side, we can see that there is some Z banding. So I'm going to have to take some tweaks to the TiVo Tornado and see if I can get rid of that Z banding. But besides that Z banding, the quality of the layers look really good. So like I said, this was 0.4 millimeter layer heights. And it looks rather consistent, again, besides that Z banding. So let's take a look at what a 0.6 millimeter layer height will look like. And here's the 0.6 millimeter nozzle. You can see the very, very thick layer lines. These look awesome. I did only print this one with a single shell, so you can see the infill marks on the side here. Those scars are from where the infill is. But that should go away if you print it with multiple shells, like I did with the first test cube. Again, the top surface looks pretty good. There's a little bit more gaps there on the left side. But other than that, that looks pretty good. And then these layer lines, oh man, look at that beautiful 0.6 millimeter layer line right here. So thank you all for joining me as I swapped out my old 0.4 millimeter nozzle with a nice new 0.8 millimeter nozzle. As you can see, it didn't take a lot of effort. I did this within 30 minutes and I was up and running again. So don't feel afraid to upgrade and play around with your own 3D printer. And if you want to pick up this nozzle pack, I'll have a link to it down below so you can grab one for yourself. And if you have any experience with swapping out nozzles, or if you had any pitfalls or comments, leave those down in the comments below. I would love to hear your thoughts and learn from your past experiences. So again, thank you guys for watching, and I'll see you all next time.